Okay, so what we are going to look at today is just combining some of the exponent laws. So the exponent laws, a quick review from yesterday. We had the product law that said if the bases are the same, you can add their exponents to simplify it. The quotient law said if the bases were the same and I was dividing, I could subtract the exponents. We had the power of a product law that said if I have a product inside a bracket and then I have that exponent, so if I have something like a 3xy to the power of 4, that power of 4 goes to everything inside the bracket. So it'd go to the x, to the y, and to the 3. And the same thing for a quotient. So instead, if I had 3x over y to the power of 5, that 5 would go again to everything inside the bracket. And then the last one that we had was the power of a power law, which is if I had x squared raised to the power of 5, I could multiply those two exponents in order to simplify it. So now we're just going to look at combining those laws. So 3 students are attempting to simplify the following expression: 3x squared times 5x cubed. Their answers are shown below. Harry says that the answer is 8x to the power of 5. Janet says it's 15x to the power of 6. And Laura says it's 15x to the power of 5. Explain using factors which student is correct. So by using factors, it means break this apart. So if I take 3x squared and I break it apart, what would I end up with? 3 times, okay, and then I would multiply that by 5 times x times x times x. And order doesn't matter when I multiply. So because everything is being multiplied together, I can take the 3, multiply it by the 5, which gives me 15. And then if I take the x's, how many times am I multiplying x by itself? 5 times. So as a power, that would be x to the power of 5. So which student was correct?
Laura.
Laura. What did Harry do? Because Harry got the x to the power of 5.
He added the 3 and the 5.
He added the 2 coefficients. Remember, these are called coefficients. Janet multiplied the coefficients, but what mistake did Janet make? She multiplied the exponents instead of using my product law. Bases are the same and I'm multiplying, I add the exponents. So by using factors, we can show why Laura was correct. So question 2, or part 2, says use factors to explain why 6a to the power of 6 divided by 3a squared would equal 2a to the power of 4. So using factors, we're going to split this up. So I'm going to take my 6a to the power of 6 and I'm going to divide, or I'm going to expand it up. And then I'm going to take my 3a squared and I'm going to expand it up. Now remember, this line is a division bar, so we can think of it as dividing. 6 divided by 3 becomes 2. So that gives me a 2. What is a divided by a?
Nothing.
Not nothing.
0.
Not 0.
1.
It's 1. 1 whole. And a divided by a, 1 whole again. So I've got my a's canceled out on the bottom. What am I left with down here?
1.
I'm left with a 1. So do I have to put it over 1?
No.
No, it's basically I've gotten rid of the denominator. And how many a's do I have up on the top?
4.
4. So I have 2a to the power of 4. So coefficients we treat using the same rules that we've used since elementary. When I'm multiplying coefficients, I multiply the numbers. So 4 times 2, I get 8. 6 divided by 3, I get 2. 5 times 3, I get 15. And the powers, the things that have the exponents on them, that's when I use my exponent laws. So if I look at class example number 1A, if I want to simplify this, I can expand it out like I did up here, but that starts to get time consuming after a while. And really, we're mathematicians. We want to know what the pattern is so that we can use the pattern all the time. So how can I simplify this without expanding it all up? What can I do? 4 times 2 is 8. So I can take the 4 and multiply it by the 2. Then I have to take this x to the power of 5 and multiply it by x to the power of 3. Bases are the same. I'm multiplying. So what do I do to the exponents? Add them. So 5 plus 3? 8. So I get 8x to the power of 8. So I'm going to give you about 5 minutes, and I want you to see if you can do the other 6 questions. 5 questions? 5 questions. Okay, so if I look at the next one, negative 7a to the power of 8 times 6a to the power of 12, what would I get for an answer, Tyrone?
Negative 42.
Okay. If I have 20y to the power of 20 divided by 5y to the power of 5, what would I get for an answer? Connor. It's because Tyrone's...
Y to the power of 15.
There we go. It's all Tyrone's fault. He's pointing at you.
It's okay. Be a different story if I didn't.
If you didn't know it. 30b to the power of 14 divided by 45b to the power of 10. Jonathan.
2/3 B to the power of 4.
So did you write it like this, or did you write it like that? Does it matter? Okay. Does it really matter? Are these both the same thing?
Yeah.
Yes. So I could put the 2b on the top and the 3 on the bottom, or I could write the coefficient as a 2/3 times b to the power of 4. Either way is correct. Okay? What if I take 3a to the power of 4, multiply it by a to the power of 5, and then multiply it by 6a to the power of 3? Raylan, what would I get?
8 to the power of 12.
Yes or no?
Yeah.
Okay, and the last one. Negative 16n to the power of 5 divided by negative 2n. Deleta. That is correct. For class example number 2, we just start working with variables. Instead of having number coefficients, we have different variables. I can do the same thing. I can collect my x's and I can collect my y's. So all of this is being multiplied together. When the bases are the same, what do I do to the exponents? Add them. So 5 plus 3?
8.
And then 8 plus 4? And there becomes my answer. So if I look at B, bases are the same and I'm dividing, so what would I do to my exponents? Subtract them, and what would I get when I subtract them? X to the power of, and y to the power of. Okay. In C, I have numbers and I have letters, so we'll just take them one at a time. Look at our numbers first. Negative 3 times 1 times negative 4. Why did I say 1 here? Because it is a 1. If there is no start over. If there is no coefficient, the coefficient would be equal to 1. Okay? Let's look at our b's. B times b cubed times b squared. How many b's do I have altogether? 6. B to the power of 6. And then c times c squared times c would be c to the power of 4. Okay. With D, I have 10 divided by 4. When I go 10 divided by 4 in my calculator, it gives me a decimal. But the question's given to me as a fraction, so I should probably keep it as a fraction. So if I can't divide it evenly, what I look for is what can I divide 10 and 4 by?
2.
2. 10 divided by 2?
5.
4 divided by 2? Okay. Then division means I subtract the exponents, so 8 minus 4 becomes 4, and 12 minus 7.
5.
So I can write it as 5e to the power of 4, f to the power of 5, all divided by 2, or I could write it as 5 halves e4 f5. This actually tends to be the more common way that we'll see it when we get into further math courses, rather than keeping my coefficient as a fraction.
1, 5, 6.
Okay? So we just have more examples. That's all we're going to do, is as many examples as we can get through, which will be all of them, and then the questions to practice. So you'll get a lot of different variety to go through. So if I look at class example number 3, this is my product law, my power of a product. So the exponent 3 is going to go to the coefficient of 3, and it's going to go to the x. So what is x squared raised to the power of 3?
X to the power of 6.
And then that 3 to the power of 3, I can actually calculate out
27.
to give me 27. Thank you, Jonathan. Okay. Now, if you want, when you're doing these, you can separate them like I have, or you can eventually just do that part as mental math. So with b, negative 2 squared, a squared squared, b cubed squared. So I can split my product out. What's negative 2 squared?
-4.
Not negative 4.
Positive.
Positive 4, because the negative 2 was attached in the brackets. And then a to the power of 4, and b to the power of 6, because this is multiplying the exponents this time. What should I do with c?
Add them together.
Add them first, so simplify the top and the bottom first. So x to the power of 5 times x to the power of 3 would be x to the power of 8. And x squared times x would be x to the power of 3. Division, then I would do the subtraction. Thank you, Kate. And what would I get? X to the power of 5. And the last one in this example. This negative means either the top is negative or the bottom is negative. Only one thing in this whole grouping is negative, so stick it with the number. Negative 2 cubed. A cubed over y cubed cubed. So that 3 goes to everything inside, but the thing to remember is that negative only goes to one part of all of those because they're all being multiplied together. So put it with the coefficient. If there was no coefficient, make it a -1. So if there was no 2 here and it was just negative a, I would write this as a -1 to the power of 3. So what is -2 to the power of 3? -8. And then I have a to the power of 3 over y to the power of 9. Okay. Question 4. Remember what I said? If there is no coefficient, what coefficient would I have there? 1. So this would be a negative 1 to the power of 5 and an n squared to the power of 5. What is negative 1 to the power of 5? Would be negative 1. And what's n squared to the power of 5? N to the 10. And what happens to my negative of a negative 1? Becomes positive. So do I need to put the positive 1 in there? Nope. All I need is n to the 10. What would you suggest we do with B? How would we tackle question B? What would you do first, Kirsten? Okay, so tell me what you mean by simplifying it. What would you do?
Multiply the 3 and the 4.
Okay, multiply the 3 and the 4, I get 12. Okay, and then I still have this y to the power of 3, this x to the power of 6 over 6x to the power of 5. Then what? Am I done simplifying?
Multiply your exponent.
How do you mean by multiply my exponents?
Like the power.
Like bring the 4 inside?
Yeah, you have to like multiply like the cube. You have to multiply by 4.
Okay, before I take care of this 4 though, I want to see, have I simplified everything inside the brackets yet? Can I simplify this 12 and 6? 12 divided by 6 is 2. And there's my y cubed. Can I simplify this x to the power of 6 divided by x to the power of 5? And I would just get x. And again, that whole math notation, x comes before y. So let's put x before y. And then it's everything to the power of 4. So then I have that 2 to the power of 4, x to the power of 4. And if I take y to the power of 3 and I raise it to the power of 4, what would I get? Y to the power of 12. The last thing that I want to do is I want to check that my coefficient is simplified. In other words, can I evaluate or tell me what the value of 2 to the power of 4 is? 16. So I get 16 x to the power of 4, y to the power of 12. Okay, so if I look at C, the brackets are not around the outside, so I'd have to simplify the top and the bottom before I could do that division. Because the division bar is kind of like order of operations. It means do what's on the top first, do what's on the bottom second, and then divide the two answers. So on the top, 16, that 2 goes to everything inside the brackets, so I would get x to the power of and y to the power of. On the bottom, that 3 goes to everything inside the brackets. So if I go 2 to the power of 3, what would I get? 8. And then if I go x squared to the power of 3, 6. So now I have 16 divided by 8. 2. x6 divided by x6. Not nothing. It's 1. Okay? I don't want you to use to think that it's nothing. It cancels out. I'd rather you use the word it cancels out than to say it's nothing. And then that would leave me with y to the power of 10. So in D, the 2 goes to everything inside the bracket. So if I take the 2 to the 5, so 5 to the power of 2, 25, a squared, b to the power of 12, and then I multiply that by my 4a squared b. So then I multiply my coefficients. 25 times 4, 100. A squared times a squared, 8. power of 4, and b to the power of 12 times b.
B to the power of 13.
B to the power of 13. In class example number 5, we have a -1 as our coefficient. So we're going to see how that -1 impacts my questions. So if I have negative a to the power of 6, think of it as being a -1 times a to the power of 6. Now take that -1 and raise it to the power of 6. What would I get? Do I get a -1? I get a +1 because I'm multiplying it by itself 6 times, or an even number. Every 2 times that I multiply a -1 by itself, I get a positive value. So 2 gives me a positive value, 4 gives me a positive value, and 6 will give me a positive value. So I will get a +1 and an a to the power of 6. The same thing with my -a to the power of 4. Think of it as a -1 times a to the power of 4. So what's -1 to the power of 4? +1. So I don't need to put the +1 in there. So I get a to the power of 6 divided by a to the power of 4, which equals a to the power of 2, or a squared. In B, because the negative is not inside the brackets, this is like a -1 a to the power of 6. -a to the power of 4, we did that one over here. So it's going to be positive. So I'll get -a to the power of 6 divided by +a to the power of 4. Think of coefficients. -1 divided by +1 is -1. And then a to the power of 6 divided by a to the power of 4 is a squared. So that -1 times a squared I can write as a -a squared. So with C, -a to the power of 7 will stay exactly as it is. -a cubed, or a -1 times a to the power of 3. If I take -1 and I raise it to the power of 3, what will I get? -1. And remember, I can think of this as being a -1. So -1 divided by -1 is +1, which I won't need to write. And a to the power of 7 divided by a to the power of 3. Thank you. What do I do with 6a? What would I do first? Actually, what I'll do is I'll give you 2 minutes to work on these 2 questions, and then we'll see where you get. So if we look at A, how would I approach that to begin with? Who wants to give me a strategy? What did you do first, Kate?
Like -2 to the power of 3. B squared to the power of 3.
And then b3 to the power of 3. Okay. So what is -2 to the power of 3? -8. And then a squared to the power of 3 would be a to the power of, and b to the power of, and then I can multiply that by my 4a to the power of 5, b to the power of 7. So then when I multiply the coefficients, I get
-32.
a to the power of 11 and b to the power of 16. Good. Okay. The last question, it's not a hard question, it's a tedious question, it's a time-consuming question. So it's not hard, it just means it's not going to be done in 5 seconds. So you have to get over that, I can't spend more than 5 seconds on a question. That would be ridiculous. You can, and you have to. Okay?
I did.
What?
I did A wrong.
What did you do?
I got -8, A7,
A7, 2 and 3. If I multiply them together, would I get 6?
I think I missed that 2 and 3.
Okay. Does it make sense though, Jonathan?
Yeah, it's making sense.
Okay. So what would I do to simplify this question? I would start by simplifying the top. So I have this 72, and I also have what would be a -1. If I take -1 and I raise it to the power of 4, what am I going to get? +1, which when I multiply by 72 won't change it. Then I have an x, a y, and a z. So I have an x, a y, and how can I simplify my z?
2 times 4 equals
2 times 4 gives me 8. So my top is simplified. I can't combine, I can't push anything else together. So now let's look at the bottom. I have 6, and then I have this 2 to the power of 3. What is 2 to the power of 3 going to equal? Eight. And then x to the power of 3. This y squared to the power of 3 is going to be 6. And then I have z 8. I just don't need brackets there. Z to the power of 8 and y cubed. Right? So the top is simplified. I can't do anything more, but I still need to work on the bottom because the bottom is not simplified.
It's Z to power of 8.
What's that?
Isn't it Z to?
Yes, it is. Six times 8. 48. And then I have an x to the power of 3. I have no other x's, so it will stay. I have a y to the power of 6 and a y to the power of 3.
Y to power 9.
Y to the power of 9 because they're being multiplied, so I add the exponents. And z to the power of 8. Now that the top and the bottom are simplified, now I can look at dividing. So 72 divided by 48
3 halves.
gives me my 3 halves or 1.5. x4 divided by x3. y10 divided by y9. And z8 divided by z8 is 1. Cancels out. There's my final answer. Or it could be written as 3xy over 2. Okay, so your questions. I'm not going to do the next 2 because the next 2 are a little bit of an extension and I don't think that we need to get to that level right now. So question 5, B and C, 6, B and D, 7, B, 9, B and D, and then 10, 11, and 12.